So, this is the lecture 4 and we will do the numericals of Newton's laws of motion, which are given in your textbook, page 287. So, you see the first question, starting from rest. Starting from rest means initial velocity is 0. A body of mass 100 kg, m is 100 kg, attains a velocity v, final velocity is 40 meter per second, and in how much time? 10 seconds. You have to find the force acting on the body. So what is the one way of doing this question? V is given, U is given, T is given. You can find A, acceleration A, by using V equals to U plus AT. It's clear. I am just writing the hint. It's clear. When you will calculate it, what will be the value of A? Value of A will come out 4 meter per second square. Full calculation you can do. It's clear. So what will be the force? M into A. M into A, 100 into 4. That is 400 Newton. This is the one way. What is the another way? You find out the change in momentum. So see here, change in momentum, m into v minus m into u. Initial momentum will be 0. So change in momentum will be equal to the final momentum. That is equals to 40 into 100. That is equals to 40,000, 4,000. 4,000 kilogram meter per second. It is clear. So what will be force? F equals to delta P upon delta T. What is the delta T? It is the time interval in which this change in momentum took place. So that is 10 seconds here. So that is equals to 4,000 upon 10. That is 400 Newton. It is clear. What is the unit of delta P upon delta T? It is Newton. It is a very common question. What is the unit of delta P upon delta T? It is same as the unit of force. That is Newton. It is clear. Now see the second question. A force of 200 Newton. F equals to 200 Newton. Acts on a body of mass 2 kg. Initially at rest. In the question it is given U equals to 0. For 10 seconds. T is given how much? This force is acting for 10 seconds. You have to find the final velocity and linear momentum. Very simple. By using these two, you can find acceleration. What will be acceleration? Force upon mass. I am not doing the full calculation. Full calculation you will do. Force is 200 Newton. Mass is 2 kg. 200 upon 2, that is 100 meter per second square. So what will be the final velocity? V equals to U plus AT. U is already given 0. U is already given 0. 0 plus 100 into time is how much? 10 seconds. That is 1000 meter per second. So what will be the linear momentum? Linear momentum P equals to M into V. M is given 2, V is given 1000, that is 2000 kilogram meter per second. This. Now next question you can see. Bullet moving with a velocity of 100 meter per second penetrates through a wooden block and emerges from the block with what velocity? 10 meter per second. strikes to the wooden block. This is the wooden block. It's clear. You can see here, this is the wooden block. Wooden block. This bullet is striking to the wooden block with what velocity? With velocity of 100, and emerges out from here by what velocity? 10 meter per second. If the width of the block is halved, suppose the width of the block at present is x, then what would be the velocity of the bullet after emerging from the block? मीन्स क्वेश्चन में कह रहे हैं कि अगर ब्लॉक की विड्थ को हम क्या कर दें? हाफ कर दें, मतलब x की जगह क्या हो जाए? x/2 हो जाए, और बुलेट क्या है? इट इज स्ट्राइकिंग विथ सेम वेलोसिटी 100. Then what will be the velocity after emerging from here? You have to find this velocity. It is clear. So how will you do? Here we can do this question by using work energy theorem, which you will study in the work energy power chapter and already studied in the class 10th. What is work energy theorem? Work done equals to change in kinetic energy. Change in kinetic energy. So see here, work done equals to change in kinetic energy. Here work is done against the resistive force which is applied by the wooden block on the bullet. So you assume, let resistive force, this is the average resistive force, we will call the average resistive force. Average resistive force applied by wooden block on bullet is F. It's clear. So what will be in first case? What will be work done? You can see here, I am writing here. You see, in first case, what will be the work done? This force is acting up to what distance? Up to x distance. F into x equals to change in kinetic energy. So initial kinetic energy will be more, final will be less. What is the formula of kinetic energy? 1/2 m into v square. Here m is not given, you take mass of bullet equals to m. So what will be the kinetic energy? It will be change in kinetic energy. It will be Ki minus Kf. Why do we take Ki minus Kf? Because initial is more, final is less. You simplify it, 1/2m, 1/2 into m into 100 square minus 10 square. When you will simplify, perhaps it will come out 9900 m/2 f into x. Now in second case, you can see what is the work done. Work done will be F into x/2. Now the change in kinetic energy, 1/2 into m into 100 square minus v square. So see here, in place of F into x, we can write this. In place of F into x, we can write this. So already there is one denominator, 2 in denominator. This you can see here. Already there is 2 in the denominator. (1/2) in place of F into x, what will you write? 9900 m upon 2 equals to 1 upon 2 m, this is minus v square. You simplify, m and m cancel, 2 1 power each cancelled. So what will you get here? I am writing here, it's clear. You can see 9900 upon 2 equals to minus v square. So when you will simplify, this is 20,000 2v square. So what is 2v square? It is perhaps 10,100. So v square, so that you can do 5050. So v equals to square root of this. So that you can find it. It's clear. So you will do by using work energy theorem. And another way is what? You find out the acceleration. It is clear. Acceleration means retardation. You find out the retardation by using the first case and then do. So that way also you can do. Now all of you see the question number 4. A force of 16 Newton acts on a ball of mass 80 gram for 2 microseconds. Find the impulse. So already I have told here, this is what? F equals to 16 Newton. What is time here? 2 microsecond. Microsecond means 10 की power minus 6 second. So what is the formula of impulse? Impulse equals to product of force and time, F into T. What is F here? 16. This is 2 into 10 की power minus 6. That is equals to 32 into 10 की power minus 6. That is 3.2 into 10 की power minus 5. Now see here, what will be the unit of impulse? In the previous lecture I have not told about the unit of impulse. So one unit is unit of force multiplied by unit of time, that is Newton second. There is another unit, as we know that F into T is what? Delta P. And what is the unit of P? Kilogram meter per second. P equals to m into V, P equals to m into V, therefore kilogram meter per second. So all of you remember one thing, that the unit of momentum is kilogram meter per second. Unit of momentum is also Newton into second. Unit of impulse is kilogram meter per second. Unit of impulse is this is also. इट्स क्लियर. मतलब ये दोनों क्या है? इम्पल्स की भी यूनिट हैं, ये दोनों मोमेंटम की भी यूनिट है, और यही दोनों क्या है? चेंज इन मोमेंटम की भी यूनिट है. नाउ सी द नेक्स्ट क्वेश्चन. सो a hammer of mass 1 kg, mass is given 1 kg, with initial velocity u 10 meter per second, hits a surface and come to rest in how much time? 0.2 second it will come to rest. Suppose this is the surface, this is the surface, and this is the hammer. It's clear. It is moving with what velocity? 10 meter per second. It come in contact to the surface part for 0.2 second, and in that 0.2 second its velocity becomes 0. You have to find the average resistive force acting on the hammer and impulse. So see here, what will be the average resistive force? That will be equal to delta P upon delta T, rate of change of momentum of the hammer. So what was the initial momentum of hammer? 1 into 10. What is the final momentum? 1 into 0. This is the change in momentum. This change in momentum take place in how much time? 0.2. So this will be equals to 10 upon 0.2. 100 upon 2, that is 50 Newton. This will be the average resistive force. Average resistive force. Then impulse will be equals to what? F into T. F into T or F into delta T, anything you can write. So F is 50, T is given how much? 0.2. So this is equals to 10 Newton second. 10 Newton second. Now see the next question. A player stops a ball of mass 200 gram. Mass 200 gram, that is equals to 0.2 kg. Towards him with a velocity 20 meter per second. Means ball is coming with what velocity? 20 meter per second. And player stops the ball, that is V equals to 0. If the ball remains in contact for how much time? 0.1 second. It is given in the question. Find the impulse and resistive force. So impulse will be equals to what? As we know that impulse equals to delta P. What will be delta P here? It is M into U minus M into V, because initial momentum is more. Final will become 0. So it is 0.2 into 20 minus 0. That is equals to 0.4 Newton second. Now you have to find the average resistive force. So we know that impulse equals to what? F into T. So what is F? Impulse upon time 0.4 upon 0.1, that is equals to 4 Newton. This will be the average resistive force acting on the ball. Then next question. A body starting from rest U equals to 0 attains a linear momentum, means उसका momentum कितना हो जाता है? इतना. Under the action of how much force? 250 Newton. How long does the force acts on the body? So initially it is at rest and momentum becomes this. After certain time momentum becomes this. You assume that let force acts for time t. So now we know that the impulse is what? Change in momentum. What will be the impulse here? 250 Newton force is acting what? For what time? T time. So this is 250 into T equals to what is the change in momentum? Final is 125, initial is 0, that is 125. So what will be T? 125 upon 250, that is 1 by 2, that is 0.5 second. It will be 0.5 second. Now from question number 8 I will tell afterwards.